quick update on what is going on with the mill. The way that my current head is set up, the drive gear is sitting on a 22mm milling arbor, and that means that I basically have to disassemble the entire milling head if I want to take it off, which is a shit design. The original design, you would have a Morsefort W20 adapter. In the W20 adapter would be basically a fake collet with a drive slot in it, and then the drive gear has a shaft which has a tang on the end of it, and that it works, but it's a bit of a shitty system because the tang gets buggered up. I was looking around for something that would do much the same thing, but would not require me to make a tang and harden shit and then have to deal with stuff getting bent and all the rest of it. And I remembered that what I actually have lying around is the remains of a Simca gearbox, of which this is the lay shaft, and that was one of the gears that sits on this splined portion. So what we have here is a Morse 4 to splined drive. That's the second attempt, and I didn't get my shrink fits exactly perfect, so that's sticking out a bit still, which is a bit of a bugger. My first version I got the shrink fits perfect, but then fucked up the taper, something rotten. And it's one of those things where you have to do the shrink fit first, because otherwise you mess up the taper that you've just cut. So that works anyway, and will drive the shaft. So what we'll have here is the, if we come back down to here, we will have the drive gear on here, roughly this position, and that will go through the big giant butt plug of death, and this 20mm section will run in this gear, and it won't go through any further because it's sat on the lathe table. So the big giant aluminium butt plug of death is finished, and on the other side we need something to hold this in place. Now the problem with that is that there's a reserved area here, because this needs to engage in the mounting plate as a pivoting point, and yeah, we don't have enough headroom here to put in a shaft collar. So what we are going to be making is a taper lock collar from this piece of steel, and this piece of aluminium. Now, a taper lock collar, basically you have a what's kind of a split collet that sits on the shaft. It's got a tight fit on the shaft. It's split down the side. It has two little stub holes here and a threaded hole that goes all the way through, and then it's bored, in fact they're on the outside, and then it's cut to be tapered. And the same thing happens here. You have one stub hole and two threaded holes, and then you bore the whole thing out, and you use a couple of what are they called? Grub screws. So the grub screws engage in the threaded part of this, and they push on the flat stub end of the two holes here and squash this into the taper that's in here, and they lock really fucking hard. And then when you want to take it off, you take your two grub screws out, and instead you do the opposing action by threading into this and pushing against there, and that pulls the collar out. They are wonderful pieces of equipment. Now they're also very cheap, but they're very cheap and they're too large. I can't find one that's small enough to go in here, because otherwise I'd just buy one. So that's what I'm going to be working on. So I've got to set these up in the mill and drill them, and then we'll put them back into a 4-jaw, and we'll do the tapers. Right. So where are we? Yeah, I've pre-drilled the holes here. They're drilled 4.2 because we're going with M5. These two need to be stub holes. They therefore need to be 5mm stub holes. They need to have a flat bottom, so I need to grind up a flat 5mm drill. But first of all, I'm going to have to drill them with a 5mm drill, just to get some edge in there to support the flat bottom drill. We are using the DRO for this. You will notice over here, perhaps, what I have done some calculations and written on the table the DRO locations. That's a handy tip, that one. Three. Let's go put that 4. Right, there we go. And that, as they say, is that. Now it remains to do the same thing on the other piece, but the other way round. So 2 fully tapped holes, 1 stub. Looks alright. So there we go. Let's use some more light on that. Needs a bit of deburring. So we have the blind hole here and two threaded holes here for pulling the inner cone in. We have a 2-degree cone, and yeah, I'm going to need to polish that a little bit on the inside because the surface finish is not fantastic. But there you go. So we'll get on with that, and then yeah, we need to turn this to match to go inside. Hey. So, yeah, focus you fucker. That's that sorted. It's ready to go. It's got a slightly wonky hacksaw cut slot in here. Does actually need trimming down slightly on here, and I could probably do with losing some girth on here so that I can use this inner cone to preload the bearing. But it does work. It fits. It locks. It's nice. There we go. It was a quick project. There you go. Motherfucker. See you around, guys and girls.